Hello, welcome to Lesson 5 of the Practical OSPF series. In this lesson, we're going to configure OSPF together on a couple Cisco routers. This will give us a chance to prove everything that we've learned so far in this series, and of course, teach you how to configure and verify OSPF on Cisco routers. Before watching this lesson, I highly recommend looking at the prior videos in this series. In those lessons, we took a practical look at many fundamental OSPF concepts. We took a look at the OSPF tables that are used in OSPF. We took a look at the concept of a link state database and a link state advertisement. We looked at the different packets that are involved in every OSPF conversation. We took a deep dive into hello packets and showed you everything inside a hello packet, to include the fields which must match for two routers to form an adjacency. We also looked at the entire neighbor adjacency sequence, and we looked at every state that is involved in the neighbor adjacency process. We, of course, also talked about OSPF areas. We discussed the idea behind OSPF areas and their purpose. And of course, that let us discuss the types of routers you'll see in OSPF. If any of that is unfamiliar to you, I'd highly recommend taking a look at the prior lessons in the series. Now, as for us, what we're going to do is prove all of those things to you using a live configuration. But nothing that happens on this channel is intentional. So we're not just going to prove what you already know. We're in fact going to use the guise of proving what you know to teach you how to configure and verify OSPF. We're going to show you the basic OSPF tasks that are common to all OSPF deployments, and we'll show you a bunch of show commands that you can use to prove the operation of OSPF on a Cisco router. With that said, let me show you the topology that we'll be using in this lesson. Here's the topology that we're going to be using in this demonstration. Our topology has two routers, router 1 and router 2. They are connected via a single Ethernet link using the IP address 10.0.12.0/29. Router 2 has the IP address .2 on this link, and router 1 has the IP address .1 on this link, and both routers have 3 loopback interfaces with additional networks that we're going to be using to advertise into OSPF. To begin, nothing OSPF has been configured. All we have configured so far is simply the interfaces that you see in the topology illustration. And we can verify this by doing a show IP interface brief. This will show us all the interfaces we have configured on router 1. Now, most of the time, we don't need to actually see everything configured on router 1. Notice there's a lot of things that are not configured. So instead, most of the time, we're going to be using this command. We're going to exclude any line that includes the letters U and A. What that'll do is it'll omit from the configuration output any line that includes the word unassigned. This way, we can use this abbreviated command to just see the interfaces that are actually active in this topology. And as you can see, we have Ethernet 00, which has the IP address 10.0.12.1, and we have the 3 loopback interfaces as well. We can do this exact same thing on router 2 to see the configuration on router 2. And again, as expected, we have this as the IP address for Ethernet 00, and of course our 3 loopback interfaces. At the moment, there is IP reachability on this link. If I do a ping 10.0.12.1, we can see that router 2 can ping router 1, and router 1 can ping router 2. So this is our starting point for this demonstration. Next, we're going to start configuring OSPF. Now, throughout this demonstration, I'm going to show you a lot of show commands. And what I'm going to do is I'm going to show you the show command before we configure something. Most of the time, you won't see anything. Then I'll configure something, and then I'll show you the show command again so you can see how the output is different. This way, you'll know exactly what to look for if you're trying to verify this configuration in the future. First thing we're going to configure is the OSPF process. This is simply turning on OSPF on the router itself. But before we do that, I want to show you a show command you can use to verify if a router is doing any type of dynamic routing. You can use the command show IP protocol. That'll show you any type of dynamic routing that the router is doing. Initially, you see this right here. This is actually there by default. What I want to draw your attention to is the fact that there's nothing else in this output at the moment. But you'll see once we configure OSPF, something will change with this output. Now, to configure OSPF, we're going to jump into global configuration and type router, OSPF, and then a process ID number. That process ID number lets you group certain OSPF commands together into a separate process. Now remember when we told you what an ASBR was? It was a router that is redistributing routes from a foreign routing protocol into OSPF. Well, one thing you can do is actually redistribute routes from one OSPF domain into another OSPF domain. And the way that ASBR would separate out the OSPF domains is by using a different process ID number. That's the purpose of the process ID number. Now, it is pretty rare. Most of the time, you're just going to have a single process ID number on a single router, and that's what we're going to be using in this topology as well. Now the process ID number you use doesn't actually matter. You can see that you can use any number between 1 and 65,000. A lot of people simply just use 1 to keep it simple. Personally, I like to use OSPF Process ID number 110 when configuring OSPF. I'm not going to tell you why, I'll leave that as trivia. Go and tell me in the comments why you think I like to use OSPF 110 as my OSPF Process ID number. In any case, that's the only thing we're going to run on this router at this time. I'm going to back out of this and do show IP protocols again. And you'll see that now something different has appeared in the output of this configuration. We have a whole new paragraph added to the output of show IP protocols. Now, more and more is going to be added to this command as we continue throughout this demonstration, but for now, I just want to draw your attention to this is confirming we have an OSPF process ID with the number 110 configured. Notice here that the router has picked a router ID to use. 10.1.9.1 matches one of the loopback interface IP addresses. The next thing we're going to do is actually set the router ID explicitly. But notice that the router was able to pick one if we didn't explicitly tell it what router ID to use. The other thing that I want to draw your attention to is this line right here. Notice it is currently telling you that this router is in 0 different areas, meaning it's not part of any area. Well, that makes sense because we haven't actually told the router that any interfaces are going to belong to any area. So at the moment, this router is in 0 areas. And then finally, the last thing I want to draw your attention to is this line right here. This is telling you the networks that this router is currently routing for. At the moment, this is empty. You're going to see that's going to change once we add some interfaces to OSPF on this router. With that said, let's go ahead and change the router ID by explicitly setting it to something we want. To do that, we're going to jump into global configuration, and then go into our OSPF process ID, and then use the command router ID 1.1.1.1. Now, if I use the exact same command, show IP protocols, you'll see that currently the router ID is as I set it to be 1.1.1.1. So that's how you would use the show IP protocols command to verify that you are currently running OSPF and to confirm what router ID the router thinks it is using. There's also another command you can use to verify those things, and that command is show IP OSPF database. What this command is doing is showing you the link state database for OSPF for this router. Now, at the moment, there's not a lot going on because, again, there are no networks added to OSPF for now. But this command is again showing you the router ID and the process ID for OSPF on this router. You're going to see this command output change when we run the next command. The next thing that we're going to do is we're going to add interfaces to OSPF. There are 2 ways to do this. One of them is the network command, and the other one is adding an interface explicitly to OSPF. We're going to show you both in this demonstration. We're going to start with a network command. But again, I first want to show you a few show commands you can use to see the effect of the network command. To start, again, I'll draw your attention to this line over here in the output of show IP OSPF database. You'll see that change after we add something using the network command. I'll also show you this command, show IP OSPF Interface, and show IP OSPF Interface Brief. At the moment, both of those are showing empty because we don't currently have any interfaces in OSPF, but we're about to add one. To add an interface to OSPF, we're going to use the network command. The network command works like this. We're going to jump into global configuration and then our OSPF process ID, and then we're going to type in the command network. Next, it's going to ask us for a network ID and a wildcard mask specifying a range of addresses. The router is then going to try to match the interfaces on the router to that range. So I'm going to actually back out for a second and do this command again, do show IP int brief. These are the interfaces that are currently configured on my router. And I want to currently add Ethernet 00 to OSPF. So my network command is going to have to match this interface IP address. Now there's a common misconception with OSPF that the network command is actually going to send a particular network into the OSPF domain, but that's not the way the network command works. The network command simply matches an interface IP address configured on the router. In our case, we want to match this interface exactly to add Ethernet 00 to our OSPF process. So we're going to say network, and then we'll specify the IP address exactly, and then we'll specify a wildcard mask. We'll use a /32 wildcard mask to specify that particular IP address exactly. Now, if you're unfamiliar with wildcard masks, I did create another video describing wildcard masks. I'll put the link of that in the description. The next thing the command is going to ask you for is the word area. Simple enough, I'll type that in. Then I'll hit question mark, and here it's asking us for the area number that this particular interface is meant to be in. For our topology, everything is going to be in area 0. So I'm going to answer this by simply providing area 0. Now notice it'll expect the area number as a single decimal number or in dotted decimal format. Either is the exact same result. Now if I were doing multi-area OSPF, I would simply configure one interface in one area and then other interfaces in another area. In our case, everything is going to be in area 0, so we're simply going to hit enter right here. Once I hit enter, I can back out of here and run these exact same commands over here. And you'll see that now there's going to be something different. I'm going to show you the brief version of this command first. Show IP OSPF interface brief. And now it's telling me that Ethernet 00 has been added to OSPF. It is in process ID 110. It is in area 0, which is what we told it to be in. And this is the IP address and mask on that particular interface. The cost of using this interface is 10. Now, we haven't gotten into OSPF costs yet, but we will in a future lesson. But this is simply telling you that the cost of using this interface is 10. Then here, this is telling you the state of this interface is wait. Now, if I run the exact same command again, you're going to see that the state of the interface has changed to DR. What was happening is in the wait state, OSPF was trying to find other OSPF routers to see if there was another router acting as the DR, the designated router on this link. After some time, no designated router was found, and router 1 claimed that title for itself. So this output is telling us that this interface on router 1 is the designated router for the link out Ethernet 00, which makes sense because at the moment there are no other OSPF routers on that link since we haven't configured anything on router 2 at this time. So that's the brief version of this command. Next, I'm going to show you the non-brief version of this command. It's going to give you a lot more information. Most of the time, you're going to be using the brief version, but I do want to show you this command and pinpoint a few pieces of information that you might want to extract. First of all, it's telling you this interface is in area 0. It was attached via the network statement. It is a broadcast type network, which means this network does support sending traffic to multicast addresses, which means this network does support auto-discovery of neighbors by sending hello packets to 224.0.0.5. The designated router on this link is the router ID 1.1.1.1, which is router 1, and the designated router's IP address is 10.0.12.1. There is no backup designated router on this network yet, but there will be once we enable router 2, and the hello and dead intervals are 10 seconds and 40 seconds respectively. In this case, router 1 is using the defaults of 10 seconds and 40 seconds for this network type. So that's the show IP OSPF interface command. The next command I want to show you that is different as a result of running the network command is show IP protocols. You'll see now in the OSPF section, we have this in the routing for networks section. What this is telling you is that OSPF has any interfaces which match this range enabled in OSPF. And since that's using a /32 wildcard mask, we know it's any interface that matches this IP address exactly. And finally, the last command that I want to show you is show IP OSPF database. Again, this is showing you the link state database for this OSPF router. If I hit enter, you'll see that at the moment, we only have one entry or one LSA in the link state database. This is a router type LSA. You'll hear me refer to this in the future as a type 1 LSA, but we'll explore all that when we unpack LSAs later on in this series. And for now, this is simply telling you that there is a router LSA with a link ID of 1.1.1.1. That's router 1's router ID. In OSPF, every router is going to share a router LSA with every other router in the same area. In this case, we only have one router, and here you see that one router's LSA. So that's the content of router 1's link state database. Okay, so far we've done three things. You can see them all in this output. We've configured an OSPF process ID, we've configured a router ID, and we've added a single interface to OSPF. Now we're going to do those same three things over on router 2. Now what that's going to do is actually build an adjacency between router 1 and router 2, which of course means some show commands are going to change. So again, I'll show you some show commands before we actually make those changes. On router 2, I'm going to show you the command you would use to verify if an OSPF neighbor exists. That command is show IP OSPF neighbor. And you'll notice that at the moment, this is showing up as empty. And with that said, we will now do these same three commands, but we'll do them from the perspective of router 2. First, I'm going to jump on global configuration, and I'm going to type router OSPF 110. Again, the OSPF process ID does not need to match, but it doesn't hurt anything if it does. So I'm going to continue using 110 for OSPF. For router 2, I'm going to use a router ID 2.2.2.2, and I'm going to add this interface into OSPF, again using the network statement to explicitly match that IP address. The command will look like this: network 10.0.12.2 wildcard mask 0.0.0.0 area 0. Once I hit enter, you're going to see something happen on the console. Notice this is telling us that something happened to router 2. It's saying that for process ID 110, we now have a new neighbor 1.1.1.1, that's router 1, and the neighbor state went from loading to full. You see the loading is actually wrapped around the line over here. Remember, full is the happy state. That's the final state in the neighbor adjacency process. This is telling you router 2 has just learned a new neighbor. If I back out of the router process, I can do show IP OSPF neighbor, and this will confirm that router 2 is indeed neighbors with router 1, and that neighborship is in the full state. Notice it's also telling you that router 1 is the DR for this particular link. We can assume that router 2 is going to be the BDR, and we can jump over to router 1 and run the same neighbor command, show IP OSPF neighbor, to confirm that router 2 is indeed the BDR for this link. So router 1 has just become neighbors with router 2, and that's probably caused router 1 to learn something from its new neighbor. Notice up here, when we did the show IP OSPF database command, we only had a single router type LSA in our output. If I do show IP OSPF database again, and I hit enter, we'll see there are new entries in this database. First, you'll see that there is a new router LSA in this area. This router LSA is announcing the existence of router 2. Notice there's also a third LSA down here. You'll hear me refer to these as type 2 LSAs. This network LSA is announcing the existence of the link between router 1 and router 2. Notice the advertising router for this particular LSA was router 1. That'll make more sense when we unpack the LSAs in a future lesson. I just wanted to show you at this point the difference in the show IP OSPF database command now that we have a new neighbor. Remember that the purpose of OSPF is to share routes. And while OSPF can make great use of this particular output and the link state database, you and I are much more accustomed to looking at routes in a more traditional route format. But lucky for us, there is a command you can use that'll allow you to view the contents of the OSPF database in a way that looks more like routes. And that command is show IP OSPF rib. Rib stands for Routing Information Base. It's a technical way of saying the routing table. In any case, this is showing you the routing table that OSPF has learned about. And at the moment, there's only one route in that table, which makes sense because we've only added one interface on each router, and it happens to be the exact same link to this topology. And that's what you see in the show IP OSPF rib output. Now notice the greater sign in this output. This greater sign indicates that this route was installed in a global rib. Now that greater sign would appear right there, and at the moment it doesn't. The reason it doesn't is even though OSPF knows about this particular network, the router already knows about this network via a directly connected route. And a directly connected route has better precedence than an OSPF learned route. I unpacked the idea of router precedence in a separate video. I'll link that too in the description. In any case, that's why at the moment there are no routes that begin with the letter 0. 0 would indicate an OSPF route. You can view this another way by doing the command show IP route OSPF to simplify the routing table to only show you OSPF learned routes. And of course, at the moment, there are no routes learned via OSPF. And there won't be until we do what's next, which is to add these loopback interfaces into OSPF. And once we do that, you're going to see the output of show IP OSPF database, show IP OSPF rib, and show IP route OSPF all change. We're going to start with router 2's loopback interfaces. I'm going to jump over here on router 2 and take a look at the IP addresses we have configured. Currently, we already have this interface in OSPF. What we're going to do next is add these three interfaces, our three loopback interfaces. Each of them start with an IP address that starts with 10.2, 10.2, and 10.2. Now earlier, I told you that the network command allows you to specify a range, and any IP address on the router that matches that range will then be advertised into OSPF. I can use that to actually advertise all three of these with one network statement. I can simply match a /16 network that starts with 10.2, and that'll match all three of these networks. But first, a few show commands. To start, I want to show you what we already have configured. That's this single network statement matching a /32 IP address, this IP address, or this guy right here. We currently only have one interface configured in OSPF, that's Ethernet 0. In a moment, you'll see these interfaces added to the output of this command. Now to add these interfaces to OSPF, I'm going to jump into the OSPF Process ID. I'm going to use the network command, and I'm going to specify a 10.2 network ID and a /16 network mask using a wildcard mask. I'll specify that these are all going to be in area 0 as well. As soon as I hit enter, I can back out of here and run this exact same command one more time, show IP OSPF int brief. And you'll see now I have 3 more interfaces added to OSPF. And notice these are all /24 networks. And what you're going to see, if I jump on router 1 and I do the show IP route OSPF command, router 1 has now learned of the 3 /24 networks, even though my network statement mentioned a /16. Again, the network statement simply says, find any IP address on this router that falls in this range and advertise that interface's router into OSPF. And that's what you see here. Now on router 2, if I do show IP protocols, you'll notice that this section of the show IP protocols command matches what we have configured using the network statement, even though 3 /24 networks are actually being sent by OSPF. Okay, so we have now added the 3 loopback interfaces on router 2 into OSPF, and those networks have been sent across the wire to router 1. But what else has changed on router 1? Well, let's take a look at the show IP OSPF database command to take a look at the link state database for OSPF. If I enter here, you're going to see it doesn't look like a lot has changed. But the change is actually very subtle. It's a single character. The change is right here. When we first ran this command, the link count in the router LSA for router 2 was 1, indicating router 2 was only connected to one link. At that time, that meant that Ethernet 00 link. But then when we added 3 new links, the 3 loopback interfaces, that brought the total links that router 2 is connected to up to 4. So that's the change that we can see in this output. And again, it is pretty subtle, so I could totally understand if you missed it. Now, the link count column doesn't explicitly always map to a single link. There are exceptions to that, and that'll make more sense when we uncover LSAs in detail in a future lesson in this series. For now, the other command I want to show you that has changed is showing you the IP OSPF RIB command. Again, this shows you the OSPF database in a more route-centric manner. If I hit enter, you'll see the 3 new entries in this command are right here. And those correlate to the networks that exist on the left of router 2 that have been advertised by router 2. Notice all 3 of these include this little caret sign over here, meaning that they were indeed installed in the global RIB, or the global routing table. And again, we saw that when we did show IP route OSPF. Now, there is another way to look at the OSPF routing table that gives you a little bit more details. That again involves the show IP OSPF RIB command. We can use this command, but ask for more information on a particular entry in the RIB. This will give us more information about that entry. If I did show IP OSPF RIB and then specify 10.2.9.0, this is going to give me a little bit more information about that particular route. Now, the thing that I want to draw your attention to is that line right there. This line is telling you that this entry was learned from a type 1 LSA, that's a router LSA, with a link ID of 2.2.2.2 and an advertising router of 2.2.2.2. That correlates to these entries right here. Here is the link ID and the advertising router of 2.2.2.2, and I told you earlier that router LSAs are type 1 LSAs. So in this LSA is the information that was gathered by our router to learn that route from OSPF. And again, this confirms the additional link counts is what showed us the information that we just sent in OSPF. Okay, so we have advertised these loopback interfaces from router 2 into OSPF, and router 1 has received those routes. the last thing we have to do is advertise these networks into OSPF by router 1 so that router 2 can now see those routes. Now so far on router 1, this is what we've configured. We use the network command to add Ethernet 00 into OSPF. We could use the network command again to add the loopback interfaces, just like we did on router 2. But this is where I'd actually like to show you the other way of adding interfaces into OSPF. And that way involves going into interface configuration mode directly. So on router 1, I'm going to run this command. Oops, that's the wrong command. I meant to run show IP int brief. So here are the interfaces on router 1. We've already added Ethernet 00 to OSPF. What I want to do next is add these 3 interfaces. And the other way of adding interfaces to OSPF involves going into interface configuration mode directly. So if I jump into global configuration and then interface loopback 27, from here, I can use the command IP OSPF 110 area 0 to tell the router to put this interface in OSPF Process ID 110 in area 0. Once I hit enter, I can go back, and lucky for us, I just ran this command, which was the before verification. If I run the command again, show IP OSPF int brief, we can see that now loopback 27 is indeed in OSPF. And if I jump over here to router 2 and I do show IP route OSPF, we can see that router 2 just learned about the network that is associated with loopback 27 via OSPF. So that's the other way of adding interfaces to OSPF. But what does this do to the show IP protocols output? Well, if we take a look, earlier when we were adding things via the network command, we had entries appear there. But when we add interfaces explicitly using the IP OSPF Process ID area 0 command, you'll see the output reflected right here. One way or another, it's still telling you which interfaces are enabled for OSPF. This output happens with the network command, and this output happens when you're configuring OSPF in the interface directly. So that was us adding loopback 27 into OSPF. But we still have 2 other interfaces that we need to add, loopback 28 and loopback 29. And as you know, you can use the interface range command to configure multiple interfaces at the same time on a Cisco router. You can also use that range command in conjunction with the IP OSPF area command that we just used. I'm going to show you how to add both of these at the same time. Again, we'll go into global configuration mode. Here I'll type interface range, loopback 28 through 29. Now, of course, you and I know that 28 and 29 are sequential, so it's not really a range, but you can see how I could use this to add 30 interfaces in a row if I wanted to. And from here, I'm going to use the exact same command I used before. It's IP OSPF 110, the process ID, area 0. Once I hit enter, I can run show IP protocols again, and you'll see now I have 2 new interfaces added into OSPF. I can also verify that with show IP OSPF interface brief. And you can see here are the new interfaces I have just added to OSPF. And if I come over to router 2 and I do show IP route OSPF once again, we can now see the 2 additional networks that router 2 learned about via OSPF, which match the 2 additional networks on loopback 28 and loopback 29. So that's the other way of adding networks to OSPF, by doing so directly within the OSPF interface configuration. Okay, so with the new networks added to OSPF, we can expect to see something different in the show IP OSPF database command. Again, the difference is pretty small, but you'll see that router 1 is now advertising 4 links in its LSA. If we look at the exact same output, show IP OSPF database on router 2, what you'll actually see is that the LSDBs are 100% identical. Let me move this real quick to make that a little bit easier. Here we can see them both at the exact same time. Notice both of them have these 2 router LSAs, type 1 LSAs, and both of them have this one type 2 LSAs or network LSA. In all cases, even the checksum and the sequence numbers are identical. Again, with OSPF, every router in the area is going to have identical link state databases. And again, I can also use the show IP OSPF rib command on router 2 to show us the content of the OSPF database in a bit more route-friendly method. In this case, these are the networks which made it into the routing table for router 2, because all the other networks router 2 already knew about because it was directly connected to those networks. So that wraps up our demonstration of configuring and verifying OSPF. Hopefully that proves a lot of the concepts that you learned earlier in this series. In the next few lessons, we're going to dive deeper and deeper into OSPF. We're going to continue picking apart this protocol with the goal of making you an OSPF expert. Other than the trivia question that I asked you earlier, I also want to know from you whether you're enjoying the series so far. Let me know in the comments below. With that said, we bring this lesson to a close. The main takeaways for this lesson are understanding the commands you see on your screen right now. If you learned something, do me a favor, leave a comment, hit the like button, and subscribe. Those are 3 small things you can do to show me you value this content and the effort I put into creating it. Otherwise, I hope you enjoyed this video. I want to thank you for watching, and we'll see you in the next one.